Looking at question B1, this question is about the photoelectric effect, and it says, in an experiment to investigate the photoelectric effect, light of frequency f is incident on a metal surface. So this is your metal surface and you have light coming in like that, shown as in the diagram below. The potential difference is applied between A and B. The photoelectric current is measured by a sensitive ammeter over here, and note the complete electrical circuit is not shown. So light comes in here. The energy from the light causes electrons to jump off the surface, and that's the photoelectric effect. And what happens is they travel from A to B. So you have a charge moving. This is picked up by ammeter. You have a current. Then it says, when the frequency of the light is reduced to a certain value, the current measured by the ammeter becomes zero. Explain how Einstein's photoelectric theory accounts for this observation. Now, before they used to always think that light was purely a wave. That was how it was described. Now, if light was a wave, one would expect that if you had an electron there and this energy of the wave came, the electron would just need to wait a period of time until enough energy was transferred to jump out. But this didn't happen. If you've got light of a certain frequency, it can shine for however you like. No electrons would jump out. But if you go above a certain frequency, suddenly you get these electrons jumping out. You have the photoelectric effect. So Einstein, to explain this behavior, came up with this idea of the photoelectric effect. And basically he said that light can be viewed of photons, which are like packets of energy. And when light shines on a metal surface, an electron will absorb a photon. So it will get given this packet. Now, if this energy from the photon, if that energy is enough to cause it to jump out of the surface, you will have the photoelectric effect. But if the energy is too small, then you'll have no photoelectric effect. Now, this energy here, the energy of the photon is given by this over here. E is equal to hf. So your E is equal to hf. Your energy is proportional to your frequency. So when this frequency here is too small, the energy is too small. The minimum, remember, the minimum amount of energy required to eject an electron is given by what we call phi, which is your work function. So if phi is greater than hf, you'll have no photoelectric effect.